Welcome student. This is TTP tutorial again. Today we are going to learn a very simple subtopic in the first chapter of freshman course. Today we are going to see how we can uh, study tautology, contradiction, and contingency. So these terminologies we always use them in freshman. So let us see how we can use each of these under this topic. So we'll start with tautology. Tautology is very simple. So we just need to understand the definition. Tautology is when a compound proposition is true regardless of the truth values of its component proposition. So if at all you have a proposition and in that proposition all the components or it is true regardless of its components, then from there that uh, that kind of proposition is called tautology. It's called tautology. So now let us see how we can get this tautology. Let us solve this if it will give us tautology. So as we have seen from the previous topic, we can handle this like the same way we have been handling this kind of proposition. So this one is a compound proposition. Let us solve. Now we have how many letters? We have P, Q. We have P and Q. So let us put P. Okay, let us have a solution. Solution. Then from there, you have P. Then you have Q. Then of course you have this. Okay. You have the whole of. Okay, now you write this statement alone. Then from there you write this statement all. Then you have this. Then you have the whole statement. P Q. So now writing like this, then you can. So now after getting this, you just need to find the rows of which it is very simple for you and now it is familiar for you. So from there, for us to get the number of rows, we just need to multiply these two letters with the exponential function and represent these two letters. So it will give us 4. Now here, it is like this. Now after getting this like this, so you need to get this too, and then get this one for you to solve tautology. So now after getting this, as I said before, the first two rows will take true, then this one will take false, then also false. Then now this Q will be true, false, false. Now let us solve this. Let us solve this from this. So we all know that this one is implication. So for implication, it is said that it is false if and only if P is true and Q is false. Let us say P is true and Q is false. So meaning, so the truth then true. So this one will be true. So it is false true. Then we are getting here true false, because we are following this the arrangement of this. So now it is true for Q, then false. So meaning this one is false. So false, we are getting true. Okay. Now let us solve this. Let's solve this. After getting this one now, let us get for this. Okay. Let us now get for this. So after getting this one, We should now get from this. So they say P. Okay. So it is P implication, Q implication, P. So now this one P, let us put this one to be our Q. Okay. It is the same as we define. So now here we have in P which is true. Okay. P is true, and our Q which is this one, it is also true. So meaning it will be true. Also we have again true. So it will also be true. We have false. Okay. False. So it doesn't apply this. It will also be true. We have false, true. It doesn't apply with this, so it will be true. So now, as we have seen, this is the meaning of tautology, whereby all the components are true regardless of their component propositions. So as we have seen, the whole of this is true, meaning it is tautology. This is our tautology that we are getting. So contradiction. Contradiction is just like tautology. Contradiction is the opposite of tautology. So for contradiction is when a compound proposition is false regardless of the true values of its component proposition. So when the compound proposition is false regardless of its component proposition, therefore we will say that proposition is contradiction in a logical proposition. So now here let us solve this. So it is. So now let us represent all these statements in this format. P, we have P, then we have Q, then we have negation, Q, this. Then now you write this statement separately. This P implication Q. Then also we have this statement. This P conjunction negation Q. Then also we have the whole statement whereby is P implication Q. Then we have this P conjunction negation Q. So now let us present this thing. So now after representing every statement in this table format, now you can solve each of this until you get this statement because the what you're looking for. So now here we are going to have true, false. Then here we are going to have true, false. Then here we are going to have, here we have negation, mean the opposite. The opposite of true here will be false. The opposite of false will be true. It will be false. It will be true. So we are done now here. Then now we need to find this. So it is P by implication Q. P by implication Q. So meaning here this will be true, will be false, will be true, will be true. Then now we have this P conjunction negation Q. P conjunction negation Q. For conjunction we say a statement is true when both P and Q are true. So now here let us see, it is true, false. So meaning it is false. It is true, meaning it is true. It is false, false, meaning it is false. It is false true, meaning it is false. So now we solve this and also we solve this. So now let us solve the whole of this. So it is by implication, remember. Now let us put this to be Q, then this one to be P, then this one to be Q. So now let us see. We say for by implication, it is false if and only if both P and Q have different truth values. So when they have different truth value, that's when we say this statement is false for by implication. This by implication. So now let us see. It is true. It is true. False, meaning it is false. It is false true, meaning it is false. It is true false, meaning it is false. It is true false, meaning it is false. So as we have seen, this is the compound. This one is what we call compound proposition. So now it is false. It is false, meaning this is the contradiction that we are looking for. So let us see example 3. Contingency. This is the third. This is the third among this. Okay. So contingency is just is a compound proposition that is neither tautology nor contradiction. Okay. As we have seen for the case of contradiction, it is false regardless, and also tautology, it is true. But for this, it is mixed. Okay, you can get tautology there, and also you can get contradiction there. You cannot get them. Like you cannot get them. Okay, so you can have different truth value in contingency. You can have false, true, false, true, 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 false, like that. So now let us see how we can solve this contingency. Remember, it is neither tautology nor contradiction. So let us solve this. Okay. So let us say solution. We have only 2 letters. So it is P, Q. Then the whole statement. By implication, Q. So now let us solve. So now, here we got this. Okay. So let us solve this. Now it is P and Q, then this. So for this, it will have true, true, then false, false. Okay. Then also Q, it will have true, false, then true, then false. So remember, this is by implication, and for by implication, it is defined as it is false for by implication when both P and Q have different truth values. So when P and Q, they have different truth value, therefore the statement will be false for by implication. So now let us see. It is true, true, meaning it will be true. For by implication, it is true, false, meaning it will be false. By implication, it is false, true, meaning will be false. It is false, false, it will be true. So now, as we have seen from the definition, for this contingency, it can have different truth value. Okay, it is not like tautology nor contradiction. Okay, so when you get a compound propositions with different truth values, just know that that kind of proposition is called contingency. So this is our this is how we are going to solve this. And student, if at all you don't understand anything from tautology, contradiction, or contingency, kindly contact me on my WhatsApp and Telegram number. Then I will be able to help you there. Thank you so much.